Okay, so in this video we're going to be looking at matrix multiplication. Okay, which is our second video in the matrices chapter. Okay, so matrix multiplication. So in the first video we've seen that we can multiply a matrix by a real number at the front, okay, and that's what's known as scalar multiplication. We're going to look at what is matrix multiplication, which is a different operation, okay. So the first thing to note is that matrix multiplication can only be performed when the matrices are of a certain order. Okay, so specifically, okay, so it doesn't work for all cases in all matrices, but specifically, the matrix product AB, okay, with A and B being two matrices, so capital A, capital B, can only be performed if A is of order m times n, okay, so m rows, n columns, and B is of order n times p, okay, for some values m, n, and p. Okay. Now, you'll notice there that if I multiply A times B, then you'll notice that the amount of columns that A had was n, and the number of rows that B has was also n. Yeah? In other words, the last number in the order there for A needs to match the first number in the order for B. Okay? Now what you get out, that's the only way it can match is if those two matches, okay? That's the only way matrix multiplication can happen. Okay? So AB, so the actual result of this, when you multiply this, will be of order m times p. Okay, so that's the size of matrix we would end up with. Okay, which again was our other values in our orders. Okay, so the ones on the inside have got to match, and what you're left with at the end of the answer is your outsides basically. Okay, so just to formulate that, if I've got m times n, okay, and I'm multiplying that by n times p, then as long as these two match, you end up with a size n times p. Okay, so as long as the ones on the inside match, then you end up with a matrix with the other values. Okay, so entries of AB, so our values that we'd end up with in AB, are found by multiplying a row of A, so a row of A into a column of B. Okay, this is a lot like your dot product at vectors and higher. Okay, you're going to have a list of numbers that need to multiply another list of numbers, and you multiply the first two, and you add the multiples of the second two, add the multiple of the third, and then you add them all together, and that's how you get your entry. Okay, let's go look at that. An example will show you, will make more sense of that, okay? But it's a lot like that. But you multiply a row of A into a column of B, okay? And that's why it's going to have to match the numbers wise, okay? Otherwise it won't work. You'll have an odd amount if it's not the right pairing up. Okay, so let's look at an example, okay? So look at example 1. So we're going to have A as matrix 1, 2, 5 and -2, 3 and 6, and we're going to have B as the matrix 3, -2, 1, 4, -3 and 0. Okay, and our first question is going to be find the matrix AB. Okay, so that's going to be our first question. We're going to find the matrix AB. So what we need to do is, first of all, we need to check, does the matrix A and B, can they multiply together? Okay, well, A is a matrix that has got 2 rows with 3 columns, so A is a 2 by 3 matrix. B, well, that's got 3 rows and 2 columns. So the good thing is the two insides match, so we can multiply them together. And what we'll end up with is a 2 by 2 matrix. Okay, we're going to end up with a 2 by 2 matrix as our answer. Okay, so let's have a look at doing this just now. So we'll multiply the two matrices together. So AB, now they don't know, we can multiply them. So that's 1, 2, 5, -2, 3, 6. That is to multiply the matrix 3, -2, 1, 4, -3, 0. Okay, right. So this is what I mean by you need to multiply a row by a column. Okay, so I know I'm going to get a 2 by 2 matrix. Okay, which means I'm going to have 2 entries in each row. Okay, in my answer. So my first entry, which is in the first row in the first column, okay, well that tells me that I'm multiplying my first row with the first column in B. Okay, the first row of A will hit the first column in B. Okay, so in other words, this thing here, okay, which I'm going to highlight here just now, that needs to multiply that there. Okay, and how we do that? Well, we take the first in each. Okay, so that's going to be 1 times 3. Okay, then we're going to add the second, so that's 2 and 1, so it's going to be 2 times 1. And then we're going to add 5 times -3. Okay, so that's going to be my first entry there. Okay, that's what I'm going to have to do to work out my first entry. My second entry in that row, well, that's still the first row, but I'm now multiplying that with the second column. Okay, so I'm still in this first row here in my solution. Okay, so I'm still in the first row, but I need to do the second column now. So that's going to be 1 times -2. It's going to be 2 times 4, well, plus 2 times 4, plus 5 times 0. Okay, and that's going to give me my second entry in that row. Does that make sense what we're going to do over there? Do we see how I get those numbers in those positions there? Okay, when you get used to it, you would do that, okay, in your head, but for the first few questions, write it out so you're getting it right. Now we're on to the second row, so I'm going to do the second row with the first column, so that's going to be -2 times 3, plus 3 times 1, plus 6 times -3. 6 times -3 there. Okay, it's a little bit squished. I'll rewrite that actually. It's a little bit harder to read. Let's try that again. 6 times -3. Okay. Last one, so that's going to be our second row with our second column. That's the one thing we've not done yet. So that's going to be -2 times -2 plus 3 times 4 plus 6 times 0. Okay, so that's what I get as there. So do we all see how we get those numbers there? okay, because that's how matrix multiplication works. Now we just work out what that would give me, okay. So my first entry, if I do that, well, I've got the 1 times 3 plus 2 times 1 plus 5 lots of negative 3, and what I get as my answer should be negative 10. Okay, negative 10. If I then go to my second entry in the first row, so that's 1 times negative 2 plus 2 lots of 4 plus 5 times 0. Well, obviously 5 0 is nothing, okay. So 1 times negative 2 plus 2 lots of 4, that gives me 6, I believe. Okay. Last row, okay, so negative 2 times 3 plus 3 times 1 plus 6 lots of negative 3. That gives me negative 21. Okay. And in the last entry, negative 2 times negative 2 is 4, plus 3 lots of 4, which is 12, so that gives me 16 there. And that's what the matrix AB would be there. Okay, we've multiplied A and B, and we've ended up with a 2 by 2 matrix with those entries in it. Are we okay with that, folks? How does that sound as a first example? You sort of see the process?
Yeah.
Okay, cool. Look at a second example. So with the same matrices, we're now going to do B times A. Okay, we're going to multiply matrix B with a matrix A. So remember, B was a 3 by 2 matrix, and A was a 2 by 3 matrix. And you can see we can do this because we end up with 2's on the insides. But what that's actually going to give us, though, okay, that's going to give us our outside, which is a 3 by 3 matrix. Okay, so straight away, what this is showing you is that matrix multiplication isn't multiplicative. Okay, in other words, is for example, with the whole numbers, like 2 times 3 is the same as 3 times 2. With matrices, it's not like that. It's not commutative, I should say. Okay, A times B can sometimes give you a different answer from B times A, and in a lot of cases, it does. Okay, we're going to see that here just now. But we can multiply them because the insides match. So let's do B times A. So B times A, that's going to be our matrix 3, negative 2, 1, 4, negative 3, 0. That's going to multiply the matrix 1, 2, 5, negative 2, 3, 6. Okay. And let's work out what that would give me there. So I'm going to have a 3 by 3 matrix. Okay. So that means, let's deal with the first row. So the first row's got to multiply all these columns one at a time. Okay. So starting off with the first column, that's going to be 3 times 1 plus negative 2 times negative 2. So that's going to be my first entry in there. Okay, first row multiplied by the first column. Okay, second one's going to be 3 times 2 plus negative 2 times 3. Okay, and the third one in that row will be the first row in the third column, so that's going to be 3 times 5 plus negative 2 times 6. Okay. So that's what I'm going to get as my values in there when I sort that out. Okay. If I then go to my second one, so it's going to be 1 times 1. Go a bit faster here now, hopefully. 4 times negative 2. Then it's going to be 1 times 2 plus 4 lots of 3, 4 times 3. And then it's going to be 1 times 5 plus 4 lots of 6, 4 times 6. So that's what I get there. Last one, so it's my last row with all the columns, so that's going to be negative 3 times 1 plus 0 times negative 2. That's going to be negative 3 times 2 plus 0 times 3. And then the last one's going to be negative 3 times 5 plus 0 times 6. Okay. So what does that work out as my matrix? Well, the first entry will then come down to being 7, then 0, and then 3, and then negative 7, 14, 29, negative 3, negative 6, and negative 15. Okay, so that's what the matrix BA becomes. Okay, so you can clearly see that AB did not give us the same as BA. Okay, you can get a different answer depending on the order the questions ask you. Okay, we okay for that? You all right with that? Okay, cool. One last thing I want to show you. Okay, talking about squaring a matrix. Okay, so we'll look at example 2. Okay, so let's given the matrix A, which is 3, 4, -1, and -1. Okay, find A squared. Okay, so that's our question, what to find A squared. Now, if you think carefully about how multiplication matrices work, the only way this can work is if you want to square a matrix, it's got to be what's known as a square matrix for this to work. In other words, what is the size of A? A is a 2 by 2 matrix, yeah? In other words, it's like a sort of square size, yeah? Because they've got to match in the middle, yeah? Otherwise, because if A was a 2 by 3, you couldn't multiply an A and an A together then, because a 3 and a 2 being inside and it wouldn't work. Okay, so it's got to work with like what is known as a square matrix. Okay, so if I do A squared, you don't just square the terms as well. Okay, that's another common mistake. You've got to do A times A. So A times A is going to be 3 times 4. Sorry, 3, 4, -1, -1, multiplied by 3, 4, -1, -1. And you can see that they're both 2 times 2. So it's going to leave me with a 2 by 2 matrix as well. Okay. Okay, so we've seen this now a bit for first row with the first column be the first entry. Okay, now at this point here, you might be able to just, speed up the process a bit. Okay, maybe not write as much as you maybe have to the first time. So 3 times 3 is 9, plus 4 times -1, that's going to be -4. So you've got 9 minus 4 to work out there. That might be a quicker way to do it, friends. Okay, first row, second column, 3 times 4 is 12, 4 times -1, that is -4. Okay. Second row with the first column, so -1 times 3 is -3. -1 times -1 is +1, so -3 plus 1. And lastly, last row with the last column, so -1 times 4 is -4. And then -1 times -1 is again +1. Okay, and that would come down to 5, 8, -2, and -3. Okay with that? Excellent. Okay.